Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is going to look at your homework example here for a reverse Polish notation calculator. And so, back in my day, these calculators were very popular and they did math completely differently than what we were expecting. When these things started going out of style and people were buying these things up because they had to have their RPN calculators for the rest of their lives. Hewlett-Packards were a big one, big brand for that. So we're just going to kind of emulate that using object-oriented programming, inheritance, polymorphism. Things, we're over-engineering it just slightly, but just so you can have an example of how to use all these big things that we've been working on. And now we can even use dynamic casting to figure out how to get this thing to work more properly. So right here, I have this operands.h file. And I'm going to use that for all of this stuff you have here, mainly because almost all of these classes are going to be just empty husks. They're just going to be containers. So we can actually supply and say, hey, you're an add object. Hey, you're a subtract object. But ultimately, it really doesn't much matter. So I'm going to first create up here. Oh, I need my pragma once. Okay, I'm going to need my class operand. And let's see. Give it a virtual destructor. Virtual destructor operand. Oops, that's not a tilde. And the reason for this is apparently you'll get a weird error if you don't put this in here. And what happens is that apparently to get virtual behavior, there needs to be at least one virtual function inside of the base class or the class that you're dealing with. And if you don't, you'll get a weird error. The first couple times, I've never seen that error before. And I'm just, because I guess the cart was before the horse or something like that. So I have my class called operand. I have a virtual destructor. I do have to define it. And I'll just do it. Oops, I'll do it real quick. There does not have to be anything in here. It's just here so that you get virtualness for free. You'll get inheritance and polymorphism for free. And you won't have any memory leaks if anything ever comes up. Okay, so then that covers class operand. And then that is the base class. This is going to be the base class for absolutely everything that we're going to be doing from here on in. So now I want to have a class called number, which derives publicly from, everything derives publicly from operand. So you get all this, nothing for free. You get the virtual function for free. And let's see, this is done. That's done. Maintain a double member. Okay. For simplicity, I can make it public if I want. And again, this is just for simplicity's sake, just so that you don't have to worry about anything else. And I say I want it to be a double. I'll call it, no matter what variable I call it, I'll just call it value. And I'll probably forget that I named it as such. And I still need a constructor for this. And I'll pass in a v for the value. I'll make it easier on myself. Value goes in and v stays in. Normally, I would make this private and add, public gets and sets and things like that. But again, I'm not necessarily worried about that. So let's see. I have a class called number, derives from operand. I maintain a double member called v. And I'll just, whatever. I'm just talking. Okay, I'll just do it the other way around. Just be done with it. And for simplicity, I can make the member variable public. And I am. Okay, done. Okay, so now I say I have operand and I have number. Number moves into operand. And now I'm going to have a class called operator. Operator, which is a publicly going to derive from operand. And it's going to have nothing. This is just a placeholder. So this actually has nothing in it. So this gets all of operandness for free. It gets that virtual destructor. So again, these two, number and operator, are at the same level. They both derive from operand. And now all these other ones are going to derive from operator. And so class add public operator. Nothing here. And then I'm going to do the same thing for subtract, multiply. How many? I think there's 5 of them. I'll have to look to make sure. Subtract, multiply, divide, and then square, I believe. Come on. So divide, yep, so 5 total. And almost all of these are going to be empty classes like it says. And let's see, only the number class has a true constructor. Everything else is virtually empty, and I put them all into one file. Okay, the only thing left to do is add a little spacing between everything here. Somebody's not happy. What are they not happy about? What are they not happy about here? Non-deleted function overrides. Deleted. Hold on, let me try to build this and see what comes up. What is that error message trying to tell me right now? Okay, I'm going to figure that out and get back to you right here in a second. All right, so this is where programming in multiple languages sometimes comes and kicks you in the butt. So I needed to make that virtual destructor public. Otherwise, there's no way it's going to work, because it's like there's a private destructor, like destroy the object, please. No. So the compiler says that's not good, and you get that error. It doesn't come up quite often, but when it does, it can be a little tricky, and you just have to look in. I just looked up the message. You can see here I have documentation for that error. I figured it out, and that figured everything else out. I also had to add the constructor to number. And again, I don't normally put these all in one place, but there's no reason to have a file just for this tiny little bit or a file for this little tiny bit. So you might as well just throw them all into one place, and you can find everything as you need to. So double, the V comes in, it gets saved under the member variable value. And now everything else, this is 3 levels here. Operand is level 1. Number and operator is level 2, and add, subtract, multiply, and divide and square are level 3. Level 3 means they move up to operator, and they are parented back to operand, and same with number. So now we're ready to move on to this other part here in this separate file and everything, figure out how to make this thing work with stacks and queues, and set up basically a queue, which is basically the mathematical operation, like the complete operation, and then then we can just throw it into the calculate function and have it generate the final correct response. Okay, so the first step is just to kind of get a main going, and I stole this code and I modified it slightly, so I need to use push, not pushback, to use a queue. I'm pushing a 1 into the queue, then a 2, and then the add. So it's just a series of just 1, 2. Plus sign, if you want to think of it that way. That's how things would work, and calculate. And of course, it should print out a 3 if I get things working. And I'll just put a 3 here, because that's what it should do right now. But there's a difference between what it should do and making it do it right? But now I get an error here when I do things this way, and I get these 2 functions that I created in the operands.h. I believe I just actually have to just go ahead here and set things up, and set up the destructor, get rid of these guys, and set it up in a implementation file. I think that's why, because of just the way that the .h and the .cpp's always kind of fight each other for this kind of stuff. And it won't let me do it. That's okay, I can do it manually. Already here, and then here I can set this up. Operands.h. Again, there's nothing going on in the destructor itself. It's just there as a to make things work virtually with inheritance polymorphism, and to allow the memory leak not to occur. And then this guy, where did my, did I? Hopefully, nope. Oh man, I'm gonna have to bring it back just for a brief moment so I can get it back here, so I can set it up over in here. And that should, does that help? There we go. There go my linker errors. Linker hell is the worst hell of all the hells that are that goes into just pure programming, because you get that and you're like, well, how the heck am I supposed to fix that? And you do by, that's why we separate things from .h files, so it's not just all in one place. But there are a lot of little things that can pop up, and when they do, they cost you a ton of time. So now if I run this with everything that I've done so far, I get my 3. Yay, I get my printout of 3. And that's what I'm expecting to see here. This 3 makes it through, and now it's just a matter of playing around with this and following the rules. And here, let me put a breakpoint here, and you can kind of see what's going on. And now if X is my Q, it's got a size of 3, and you can see here that element 0 is a value. It's sitting under the hood as a number type, and its value is a 1. And this is a number object, and its value is a 2. And this guy right here is an add. You can see that. I know it's very complicated. What you're seeing versus what it's trying to tell you, but you can see there's a 1, a 2, and an add, and now we're ready to go. And at the end of the day, yes, I'm going to return something, but what am I going to return? I'm going to return this result, but I'm going to return it correctly and not just hard-coded, right? So, okay, so what does it say here? It says here, I'm going to use a stack of doubles internally to maintain numeric values, because this can be much more complicated than just 1 plus 2 equals 3. So I'm going to create a stack of double values, it says, right? Here, let me drag this over one more time. Go. Drag this over. Okay, so a couple things I wanted to get into, and I'm thinking about it. Notice I normally tell you guys to pass everything by const reference, but in this case I'm actually passing by value. I'm passing the Q by value because I'm going to be obliterating this thing, and when I pass this thing along to calculate, I don't want it destroyed. I don't want it to be a one-time, one-use only kind of thing. So if I pass this thing by value, then I don't have to worry about that because a copy is made, and so there's the original copy here and the copy, the second copy here, which I can tinker with and not have to worry anything about. So if I made this const, it wouldn't work because I'm going to be destroying it as I'm working with it. If I make it reference, then I'm going to be modifying here and destroying the real thing. So I want to make sure I pass this by non-const value. So I have my Q is set up here, my stack is set up here, and this is going to be just a stack of doubles. Make sure I do that right. The Q is of operands. We already looked that over. And then the stack is going to be doubles. And when I get to the end of this, there better be only one. I could put an assert in here if I wanted to, or something like to presume there's only one. But what I can do is just say, since this is a stack, I can return the top. What is the top element of my stack? And return that. And if there isn't one, then I get lucky every so often. But if I do this right, I don't have to worry. Okay, so let's see. I have this calculate function. Its only parameter is the queue of operand pointers. The stack of doubles is maintaining that, and for every element in the queue. So while my queue, I should probably just call it Q instead of X, right? It just queues look weird, right? While q.empty equals false, do stuff. And then return at the end of the day. So I have my stack, starts empty, but there better be something in it when I get through and I eliminate all this stuff. Okay, so now, while q.empty, I have to go ahead and remove, right? That's part of it here, is I need an operand pointer. I'll call it O, and it equals the q.front. What is my front element in my queue? And then I need to go ahead and q.pop. Notice there's no pop front or anything like that. It just does what it needs to do. And it's two lines of code. Get me the front element. Right? There's no other. There's back, there's front. Oh, there is a back and there is a front. But I definitely want the top element. I want that. I want top. Isn't there top? Nope, there's no top. There is front and back. Oh, it's a queue. In my head, I'm thinking stack. So I want the front. Yes, I want the front element, and then I'm going to pop that off. And it's presumed you're going to be popping off that. And let's see what happens. Just because I already confused myself, let's make sure that that's what we're dealing with. So I have my mouse pointer. My first O is the 1, the value 1. Okay, fair enough. And now I do this a second time, and now the O is the 2 value. And now this O is the add object. There it is. There's the add right there. So yes, everything is working properly. I talked myself into thinking I did something wrong, but as I'm going through here, the first element, basically the front element, the next one to process is being processed correctly. And now it's just a matter of dealing with, what have I got? If I have a number, what is it? If the operand is a number, simply add the value to the stack. Otherwise, we have to figure out what's going on in dynamic cast and dynamic cast and dynamic cast. So just to show you here, what I can do is I can try to convert O into an N. I'll just say an N. Say number pointer N equals dynamic cast O. I'm sorry, into number pointer O. And what this does is it says, okay, I know I have an operand. And remember back, that is like the main base class for everything. But we can work our way up, but we can't work our way down. Nor we can't just say that is a relationship. If I have a number, I know I am an operand. But if I have an operand, I don't know if I have a number. And so this is where the dynamic cast comes in. It goes, hey, O, hey, operand, are you a number? And if it returns a null pointer, the answer is no, that you are not dealing with a number. But if it returns something that isn't null pointer, I can work with it. If N does not equal null pointer, and just to show you here, I can see out the thing. I can see out N with a couple spaces. I'm sorry, I can't do N, I have to do star N. Or N dot value. Up an arrow because it is a pointer. And you can see now I get 1 and 2. I print out the 1 and 2 and it crashes. Right now, I mean, it's fine. I mean, say we're not doing anything that requires this. Just to say what happens here. Where did it crash? It crashes on the return because the S is empty and it's trying to return the top. So, but what am I trying to do here? Instead of printing out just to prove to myself it works, I'm trying to add to that stack. Push n dot value or n arrow value onto that stack. And so now when we, instead of crashing, right now the 2 numbers will go on that stack. And S is now holding 2, and now you can see there's the size, and then there's the size. Come on, show me the numbers. There it is. A 1 and a 2. And the 2 would be the first element that I would access because that's the top of the stack. So good. If it is a number, then push it to the stack. Otherwise, oh my goodness, this is where the fun is. And it really, you've done the hard work if you know how the dynamic cast is working here. And now all I have to do is just keep trying. If this was the case, otherwise I just have to keep on trying. And so I just have to say else if I try to dynamic cast O into an add pointer, does not equal null pointer. And then what I can do here is I'll just print out real quick, cout plus. Those are the only 3 operands I have at the moment, so I can just show you here. Oh, and I didn't print out the other things before, but you can see it printed out the plus. Because the 1 goes on the stack, the 2 goes on the stack, and here is the plus. And so what does it say to do if this is the case? If I can dynamic cast, well then what I want is I want to pop off the stack 2 numbers, add them together, and then push the result back onto the stack again. So I can say double A equals, let me just remember how to do this, S dot top. I can do double B equals S dot top. I'm sorry, I have to pop first. And then I do that, and then I go, well, how about I put right back onto the thing A plus B. And let's see what happens now. If 1 plus 2 is 3, if I did this right, then the top of the stack, which is size 1, holds the value 3. There it is. So the addition is being done correctly here, which is very cool. That's all there is to this. It is painful. But what about the other stuff? Okay, well, what about if it's a subtract? Then this is always the same, but just put a minus b on there. And I might have it reversed, but I believe it's the first minus the second. So so just you'd have to tinker with it to make sure I'm 100% right on that. But if I do multiply, then I just do a multiply. And if it is a divide, I do a divided by b. And square does not require, oh, sorry, square does take, nope, square just squares things. Because it's not a power function, it's a square function. And so if that's the case, I only need the one value to square. Give me one second. Okay, divide, and I call it square. And if that's the case, I only need a. And in this case, it's a times a, right? Because that's what squaring is. And now if I wanted to, I could tinker with this and I say, well, what's 1 subtract 2? That should be, oops, I should definitely get a -1 on the printout here. Oops. Ah, okay, 1 minus 2. Maybe I'm doing things, and again, maybe I'm doing things just slightly wrong. Oh, no, 1, 2, push, subtract. The top of the stack, the top of the stack. No, that's right. Because it's 2 minus 1 will get me a 1. Positive 1. Here, let me put a end line here so we can see this a little nicer. So if I do, you get 1 out of the deal because this is the top of the stack. And and again, I might have it just reversed, and all you'd have to do then for divide and subtract is just go in and reverse and make it b minus a or whatever, or just b divided by a. Okay, so let's see, how about multiply? Let's use better numbers, right? 1 and 2 they're boring numbers, right? Let's use 11 and 9. So let's see, that should get me what? -2, and it does. There's my -2. And if I do add, I'll get 20. There's 20. If I do multiply, then what do I get? Then I get 99. And if I get divide, I should get, since I'm using double for everything, I should get 9/11ths, 0.81818181, and I do. And now here's the interesting here. What about power? I'm sorry, not power, square. What if I just do square? 81. That's not, well, I mean, what am I trying to do here? This thing is not complete. It's squared 9, return that. There should probably be an assert here. Let me include C assert. Or you could put or you could throw an exception or something like that. Maybe that's a better way to do things here. If s.size does not equal 1, then I want to probably throw an exception. Something like that, right? Stack contains wrong number of elements. And now this should crash on me because I did not supply a correct equation. Because 11 9 squared doesn't finish up and get me down to 1 value. So I could do something like, okay, square 9 times 9 is 81. How about I add on top of that now, or reverse this and say multiply. What do I get out of that if I do this? And now I get a result. Why isn't it turning blue? Who the heck knows? But now I get 9801 because what did it do? I'm putting 11 on the stack, then a 9 on the stack, then a multiply on the stack, and then a square on the stack. And so onto the queue. The 11 goes into the stack, the 9 goes into the stack, the multiply happens, And so what happened, 11 times 9 is multiplied to 99. And what's 99 squared? 9,801. What happens if I reverse these? I get 891. Because what am I doing? I'm putting 11 on the stack and 9 on the stack. And when I go to square, I'm squaring the 9 and turning that into 81. So when I go to multiply, I'm multiplying 11 times 81, and I'm getting 891. So that covers everything. That does pretty much, the dynamic cast covers pretty much everything that you want to happen here. This calculate function is dirty for sure, but and dynamic casts are always bad ways of doing things. I do have another video here, not in this, I don't think it's in this class, but you could look it up. It's called the visitor design pattern. And because dynamic casts are generally bad form, and it takes a lot of processing power to do dynamic casts, and it's basically you're just poking around trying to figure out what are you, but the visitor design pattern does double dispatch, does all this cool stuff that does not take nearly as much time to deduce what you're staring at, what kind of object are you looking at. But from here on in, it would be up to you if you wanted to add more operations to it, like what does it all mean? Like square root and power and factorial, it's up to you to determine how you would, if you ever wanted to go ahead and continue on this. But we took care of it. If it's a number, push it onto the stack, and if it's not a number, then we know that there should be at least 2 numbers. There probably should be some other try catches in here, or I'm sorry, like this throw exceptions if there's nothing in the stack, things like that. But again, I'm figuring out how to correct errors come in time. And you have to understand the basic concepts of programming first before you worry about all those nitty-gritty details of handling every little thing that can go wrong in your functions, in your code, in your projects. As always, if I made a mistake or you have any questions or concerns or comments, please send them to swardb@cod.edu, or you can always get a hold of me here on YouTube. Comment below, and I'll get back to you as soon as I can. So thanks for sticking it out with me, as always, here in YouTube land. Hope you have a great day. Hope you have a great week, and I'll see you next time. See you around.